Alright guys, I wanted to do a review of some cameras here, or rather a comparison with a review of the one I have. I wanted to show you the spreadsheet that I made a while back when I was shopping for cameras, and this is sort of how I did it. So here are the candidates. Here's the QHY 16200A, the 163M, the 695A, the ASI 1600, and the ASI 183mm Pro. So I have the price in this column. Red as if it's a mark against its favor. Like this is a $4,000 camera, so I put that in red because I have a budget. And then these are like 1200 and 2900, not too shabby. And then 1180, and then this one's only 900. So we got a wide spread of prices here. And then this is the field of view for my ED80. In degrees because I was trying to tailor it towards the nebulae that I typically image. So 3¼ degrees by 2.6 for the big expensive camera, 2.1 by 1.6, and so on. And then we have the field of view for my 8-inch Newtonian reflector at f5. And I didn't want them to have too small of a field of view. For my reflector, I typically image galaxies, except for the Andromeda, and a small nebulae like the Crab Nebula and stuff like that. So these, I would kind of rethink this one here. That's fine, the 0.88 by 0.67 and so forth. I would rethink these. This is sort of an old document I made, and it has some green and red where at that moment in time I was thinking. Then we have the bit depth, a whopping 16 bits for the 16200A, 12 bits, and then another 16 bits with this other QHY, and then 12 bits is pretty typical for ASI. You could do a lot with 12-bit depth. Full well, this one was amazing, 41,000 electrons full well, and then the rest are between like 15 and 20,000 electrons. But this 41,000, that's impressive. Then we get to the readout noise. 10 electrons readout noise for the QHY. That's a lot. I put that in red. That seems a bit excessive to me. And then 2.4 and then 5. The QHYs range from 2.4 to 10 electrons readout noise at unity gain. And then the ASIs are typically a lot lower. Here's 2 samples, a small sample size, but suffice it to say 1.2 to 1.6, a little over 1 electron readout noise for these 2 ASIs. That seems pretty good to me, a lot lower than these numbers like the 10 and the 5. The minimum exposure I'm not very interested in. Max exposure I'm kind of interested in. 1800 seconds, that's half an hour. 10,000 seconds for these other 2 QHYs, that's a lot. I don't think I would ever need to do that long of an exposure, but it's good to have it. And then the ASIs are both at 2,000 seconds. That's still pretty darn good. That's over half an hour. This one and this one are both kind of heavy, around 1.5 kilograms for this guy. And then the ASIs being much lighter, about 3 times the less mass than these other 2. And they all do very well in the delta T cooling category, -40 to -45. Tomato, tomato. You're not going to run these things at max cooling anyway. And you get really good data with -20 Celsius, -15 to -20. So my final decisions for this big guy was a maybe, and then maybe the 163M. I wasn't very persuaded by the 695A, so I just said no. Probably yes for the ASI 1600, and maybe for the ASI 183mm Pro. So these are sort of the specs that I was most interested in. Now let's take a look at some of the online details. Alright, so here is the High Point Scientific page for the ASI 1600. We've narrowed down the list of cameras to the 1600 and this QHY 16200A. Now I'm just looking at the camera here and not the package deal where you get the filter wheel and all that. Let's just take a look at some of these additional specs. So I like it has that red color. It's got a nice color to it. Not that it matters too much. Alright, so it's a 4/3 inch Panasonic MN34230 CMOS sensor. The 22.2 millimeter diagonal. 16.4 megapixels with these pixel dimensions. 3.8 micron pixel size. Let's stop right there and look at these equivalent components on the QHY. So it's got a nice blue color to it. I'm not sure I'm a fan of the big clunky square, especially with the nose piece here. It might not balance properly. And remember, it's a lot heavier than the ASI. Okay, so it has the APS-H standard grade sensor configuration, also 16 megapixels, but considerably larger pixels, 6 microns. This helps with sensitivity. As the surface area of the pixel goes up, you can collect more light, but then you run into problems with having sort of pixelated stars because you have these giant pixels. The effective area is 27 by 21.6 millimeters. And there's that 41 KE readout, or sorry, full well capacity and the 16-bit ADC. Like we talked earlier, rolling shutter, does it list it over here? Okay, system gain, 0.7 electrons per ADU. And it does 1x1, 2x2, and 4x4 binning. This one has also 3x3 binning. And it's got a 256 megabyte buffer. It doesn't list any of that on here for the QHY. We have 2000 times anti-blooming factors, thermal noise of 0.04 electrons per pixel per second at negative 20 Celsius. That's really good. And then we have our exposure times, and it's a 2-stage thermoelectric cooling system. The shutter is butterfly mechanical with uniform illumination. That's pretty good, actually. And then we have this air connector for removable silicone gel tubes and a heat board for optic window of sealed CCD chamber. And another thing of note is the filter wheel in this thing is fully integrated. Like, it is part of the camera. You get 5 position 2-inch filters. And the ASI, you could buy it in a combo pack with an electronic filter wheel that's attached, and that could be 7 position 2-inch mounted filters. So that's about it. This also has a 2-stage thermoelectric cooling Peltier system. Talks about the weight and the diameter. It has an anti-reflective coating on the protective window, and it has a lot of adapters that come with it. So again, if you choose the option with the filter wheel, you get that and the filters, and it comes with these spacers, adapters, all the cables you need, and a handy little bag to keep it safe. It's got a lot of cushioning in this bag. Alright, well, I think that's it for now. Alright, so I've just cut open the box. Let's see what we got here. As always, ample packaging. A box within a box. Alright. Nothing else in there. Uh-oh. I'll clean this up later. Be very careful when cutting open this one. Let's see what we got here. Filters. This is the EFW, that's the electronic filter wheel. I'll set that aside for now. Get rid of some of these popcorns. I'm going to pause the video real quick, hang on. Alright, so I've cleaned off the popcorn things. Let's see what we got here. This is the LRGB set of filters. Here's the H alpha. Looks like sulfur 2. And the O3. They're all 7 nanometer bandwidth. That's pretty good. And last but not least, the camera. It's by ZWO. Oh yeah, let's get this opened up. And I'm actually gonna need my hands for this, so I'll be back. Real quick, I wanted to show you 2 things. This carrying case here is nice and padded and insulated. But what I really want to show you is look at that big old sensor. That's where all the magic happens. Isn't that beautiful? I can't wait to use this thing. Alright, that's all. I might show you the filter wheel later, but I'll wait till I get it all set up first.